Everyone, I am Aftabala, Maths faculty in Motion Education. So today we are going to discuss sequence and series. This sequence and series is very important topic for IIT JEE. At least one question is fixed from this topic every year. So first of all, I am going to discuss here what is called sequence, then series, and then I will come to the point what is the basic difference between sequence and series, how to identify easily sequence and series. So first of all, I am going to discuss what is called sequence. What is called sequence? Any collection with identified first term, second term, and so on. For example, 1, 5, 19, 27, 57, log 7 to the base 2, pi. So what is the meaning of this? Actually sequence, what is called sequence? Any collection with identified first term, second term, and so on. I am taking here example 1, 5, 19, 27, 57, log 7 to the base 2, pi. Means actually we can say in a simple word, we can take any random number, that should be mathematical quantities. With the help of comma, we can easily differentiate this is our first term, this is our second term, in this way this is our third term, this is fourth term, and so on. Okay, so I hope you are getting this, how to differentiate this is our sequence. With the help of comma we are differentiating, this is our first term, this is our second term, this is our third term, in this way. Okay, and there is no fixed rule, there is no fixed pattern, we can take any random number. Okay, and this, remember this point, this lower subscript should be always natural number, Okay, now I am going to discuss what is called series. So series is also same. Series is actually, it is the represented sum of a sequence. What is called series? Series is the represented, it is the represented sum of a sequence. Represented sum of a sequence. Okay, now series. So what is the meaning of this? Series, it is the represented sum of a sequence. Means actually instead of comma, if we use plus sign, then it will become series. Okay, so I am going to take same example here. See this here, this one, 1, instead of comma I am going to use here plus sign. So 1 plus 5 plus 19 plus 27 plus 57 plus log 7 to the base 2 plus pi. Now how we are going to differentiate? This is series. With the help of plus sign we are differentiating here, this is series. 1 plus 5 plus 19 plus 27 plus 57 plus log 7 to the base 2 plus pi. Okay, so I hope you are getting this. What is this? This is our first term, this is our second term, this is our third term. Okay, in this way this is our first term, second term, third, fourth, fifth, sixth, seventh. So this is our seventh term, this is our sixth term. In the same way this is our fifth term, and this one is T5. T5. Okay, so T1, T2, T3, this one is T4. Okay, T5, T6, T7. Okay, so this one is T1 plus T2 plus T3 plus T4 plus T5 plus T6 plus T7. Okay, so this is series. Instead of comma, when we are using plus sign, then it is becoming series. But one more thing you need to remember here, actually here 7 terms are there, so we are writing easily T1 plus T2 plus T3 plus T4 T5 T6 T7. But if suppose if this is like 100 terms will be there, 1000 terms will be there, then what will use? So it's very simple series here. What will do this? So in that case, if terms are like 100, so we can't write easily. So for that, what we will use? We will use summation. This is called summation. Okay, and what is the meaning of this summation? Summation means it will add all the terms. Okay, so this is called lower limit, r equals to 1, and up to how many terms are there? This one total 7 terms are there. So and it is starting from 1 and it is going up to 7. So r equals to 1 to 7. This is called lower limit and this is called upper limit. Here TR. Okay, what is the meaning of this series here? It will add the terms. If you put here r equals to 1, then you will get here T1. If you put r equals to 2, then you will get t2. In the same way, what is the maximum limit here? 7. So up to 7 it will add, up to 7. From 1 to 7 it will add the terms. Okay. In the same way, if suppose here 7 terms are there, so we are writing easily. But if 100 terms will be there, 1000 terms will be there, so simple. R equals to 1 to 100, or you can say 1000 tr. So what is the meaning of this? T1 plus T2 plus T3 up to 1000 terms. Okay, so I hope you are getting this. So what is the basic difference between sequence and series? In sequence there is no fixed rule, there is no fixed pattern. With the help of comma we can easily differentiate this is our first term, second term, and so on. In the same way, in series also there is no fixed rule, there is no fixed pattern. With the help of plus sign we can easily differentiate this is our series. Okay, first term, second term, and so on. Now I am going to discuss what is called progression. Then I will come to the point what is the difference between sequence, series, and progression. So see this here. What is called progression? Then I will differentiate what is the basic difference between progression. Okay, so what is called progression? Sequence with definite rule. Sequence with definite rule. Sequence with definite rule where we follow a fixed rule, or you can say pattern. See this here. What is the meaning of this? Here, what is called progression? Sequence with definite rule. This is very, very important here. Definite rule. Okay, where we follow a fixed rule or fixed pattern. Okay, so see this here. I am going to explain with example here. I am taking example here. First example I am taking 1, 2, 3, 4, 5 and so on. Okay, so see this here. From this example what we can say? From this example we can say that every next coming term is added by 1. If you add here 1, then you will get 2. If you add here 1, again this you will get here. Next coming term will be 3. 3 plus 1, then you will get 4. Means from this example we can say easily every next coming term is added by 1. Second example I am taking here x square, x cube, x raised to the power 4, x raised to the power 5. In this way it is going. So from this example we can say that every successive term is the product of preceding term with x. See this here. Why? If you multiply with this previous term here, if you multiply with x, then you will get this one, x square. Again here if you multiply with x, into x square, then you will get x cube. Okay, again in the same way if you multiply with x in this x cube, then you will get. Going to differentiate what is the basic difference between sequence, series and progression. In sequence there is no fixed rule, there is no fixed pattern. We can take any random number that should be mathematical quantities, and with the help of comma we can differentiate easily. Means this is first term, second term and so on. Okay, in the same way series there is no fixed rule, there is no fixed pattern. Okay, and with the help of plus sign we can easily differentiate this is first term, second term and so on. Okay, now progression. So in the progression what we are doing? In progression we need to follow a certain rule or certain pattern. With the help of that we can easily differentiate this is progression. Here what we are doing? See this, in every term we are adding 1, then we are getting the next term. Here we are multiplying with x, then we are getting the next term. Okay, so this is the basic difference between sequence, series and progression. Now we are going to discuss types of progression. So see this here, types of progression. So mainly 5 types of progressions are there. First type is arithmetic progression. First of all I am writing here types of progression. Types of progression. First type is arithmetic progression. We know that it is in short, in case you can say AP. Second, geometric progression, or you can say in short GP. Okay, in the same way here HP means harmonic progression, or you can say in short HP. and fourth one is AGP, means arithmetic co-geometric progression, you can say in short AGP. Last one is miscellaneous problems. Miscellaneous problems. Okay, so we will discuss one by one here. First of all, I am going to discuss what is called AP, how to identify this is a given series is AP. Now see this here. So first type is arithmetic progression. First type is arithmetic progression. Type number first, arithmetic progression, or you can say in short AP. Now see this, what is the meaning of arithmetic progression? Actually, progression whose terms are increased or decreased by a fixed number, that fixed number is called common difference. Okay, and if I am writing definition here, progression whose terms are increased or decreased by a fixed number, that fixed number is called common difference. Okay, and if A is the first term and D is the common difference, then a standard appearance of an AP, is, see this here, what is called arithmetic progression whose terms are increased or decreased by a fixed number. This is very, very important, fixed number. That fixed number is called common difference. If A is the first term, okay, and D is the common difference, then a standard appearance of an AP will be like this: A plus D, okay, A plus D, A plus D, A plus 2D in the same way. See this here. We know that this is our first term, A plus D, A plus 2D. This is our first term, this is our second term, and this is third term. In the same way, I want to write Tn term. So see this, what will happen here? This is the first term, so here coefficients of D is not there. So I am writing here in this way, 0 into D. We know that 0 into anything, 0. So 0 into D I am writing here. Here coefficients of D is 1 here. Coefficients of D is 2. Now see this here. Coefficients of D is here. Coefficients of D is 0. So I am writing here 1 minus 1. Okay. Coefficients of D is 1. I am writing here 2 minus 1. Okay. Here what is the coefficients of D? 2. So I am writing 3 minus 1. Now see this here, you can understand this pattern here. This is our first term, so we are writing 1 minus 1. This is our second term, okay, so we are writing 2 minus 1. In the same way, this is third term, so we are writing 3 minus 1. In the same way, if I want to write Tn terms, means nth term, so what I will write? A plus n minus 1 into D. Okay, here 3, so 3 minus 1, 2, so 2 minus 1, 1, so 1 minus 1. In the same way, n, so n minus 1 into D. So this is our last term. This is our last term of AP. Okay, and it is denoted by a small l. It is denoted by a small l, or you can say also, means this is general term of an AP. General term of AP. Okay, or you can say nth term of an AP. Nth term of an AP. Okay, so you can remember this. This is very, very important here. Nth term of an AP, or you can say general term of an AP, or you can say last term of an AP is A plus N minus 1 into D. Okay, so this is very, very important. Now we are going to discuss sum of n terms. Our next heading is sum of n terms of an AP. Now see this here. Let I am going to consider actually here, let Sn. What is the meaning of Sn? Sn means sum of n terms of an AP. So we know that first term is A. What is the second term? A plus D. What is the third term? A plus 2D. Okay. In the same way, what is the nth term? A plus n minus 1 into D. Okay. This is first term, second term, third term and nth term. A plus n minus 1 into D. This is sum of n terms of an AP. So we are adding the terms up to n. Now reverse all the terms and add them. So I am going to reversing. So what will become? Series. This one last term it will come here and first term will go at the last. So see this here. A plus n minus 1 into D. Okay. What will be the second last term? Second last term will be A plus n minus 2 into D. A plus n minus 2 into D. Okay. In the same way here, what will be this one? First term will come here. Okay, so A here. Because we are reversing the terms, this first term will come here at last and this at last term will come at the first position. This is also Sn. Why Sn? See this, it's very simple. Suppose here, suppose S equals to, I am going to consider 1 plus 2 plus 3 and I am going to reverse these terms. So it's same, it will be same 3 plus 2 plus 1. So this will be also S. Okay, so in the same way, reverse all the terms and add them. Okay, now we are going to add. See this here, what we are getting here. After adding, we will get here Sn plus Sn, 2Sn. Okay, 2Sn equals to A plus n minus 1 into D. If you add this first term and this last term, so what you will get? A plus A, 2A plus n minus 1 into 2A plus n minus 1 into D. Okay. Now see this here. If you add this here, second term and second last term, after adding you will get here 2A plus n minus 1 into D. 2A plus n minus 1 into D. Okay. In the same way here, if you add this last term and first term, so after adding you will get same 2A plus n minus 1 into D. Okay. 2A plus n minus 1 into D. Now see this here. These terms are repeating. If you observe one thing here, these terms are repeating n times. 2A plus n minus 1 into D plus 2A plus n minus 1 into D plus 2A plus n minus 1 into D. In this way, 2A plus n minus 1 into D. Means these terms are repeating n times. So what we'll do? Simple. See this here. Actually, we know that here, suppose a number is there, 1 plus 2 plus 3, 1 plus, sorry, S suppose I am going to consider a 2 plus 2 plus 2. This 2 plus 2, 4. So can I write in this way? This 2 is repeating 2 times. So 2 into 2. Again here 2 plus 2 plus 2. This 2 is repeating how many times? 3 times. So I am writing in this way. 3 into 2. This 2 is repeating 4 times suppose. This 2 is repeating 4 times. So I am writing in this way. This 2 is repeating how many times? 4. So 4 into 2. Because this same number is repeating 4 times, so we can multiply with 4. This same number is repeating 3 times, so we can multiply with 3. In the same way here, this term is repeating here, this 2A plus n minus 1 into D, 2A plus n minus 1 into D, 2A plus n minus 1 into D. This term is repeating n times, so we can multiply with n. 2Sn equals to n into, this term is repeating, so I am multiplying here with n. So 2A plus n minus 1 into D. Okay, now see this here. Now I am going to divide here both sides by 2. Why we are going to divide? Because we need Sn only. So I am going to divide by 2. After dividing you will get here Sn. N by 2 here you will get 2A plus n minus 1 into D. Okay, so this is formula for finding sum of n terms of an AP. Okay, so this is very, very important formula. Okay, when we use this formula, when n is given. Suppose if n is not given, then what we will do? Simple. See this here. Sn n by 2. This 2a we can write in this way. You can split in this way, na? A plus a. I can write a plus n minus 1 into D. Okay, now see this here. So n by 2 here. Sn equals n by Sn equals n by 2 into a plus n minus 1 into d. So we know that this is last term a plus n minus 1 into d. This is tn, or you can say last term, and this one a is first term. So I am writing here a means first term, and this one is a plus n minus 1 into d, last term. Last term is denoted by a small l, so a plus l. So this is the formula. When l is given, then we can apply this formula. Sn equals to n by 2 into a plus l. A is first term, l is last term. Okay, so you can remember this. So this is very important formula. Sn equals to n by 2 into 2a plus n minus 1 into d. When n is given, when n is not given, suppose l is given, then we can apply Sn equals to n by 2 into first term plus last term. Now we are going to discuss highlights of an AP. Highlights of an AP. Highlights of an AP means arithmetic progression. See this here. What is the first point? Highlights of an AP. What is the first point? First point is if each term of an AP, if each term of an AP is added or subtracted multiplied or divided by same number, resulting sequence is also in an AP. Resulting sequence is also in an AP. Now see this here. What is the meaning of this? If each term, first highlighted point is if each term of an AP is added, subtracted or multiplied or divided by same number, resulting sequence is also in an AP. I am going to take example here. See this here. First example I am going to take here 1, 2, 4, 6, 8, 10 and so on. Now see this here. This is in AP or not? Yes, this is in AP. How? Common difference is same. If you take difference 4 minus 2, 2, here 6 minus 4, 2, 8 minus 6, 2, 10 minus 8, 2. Okay, so we are getting difference is same. So we can say this is in AP. Now see this here. What is our point? If each term of an AP is added, subtracted, multiplied or divided by same number, resulting sequence is also in an AP. So see this here. First, what I am going to do, I am going to add 1 here. If you add here in each term, so see this, what we are getting 3, 4 plus 1 5, 6 plus 1 7, 8 plus 1 9, 10 plus 1 11. So see this is in AP or not? Yes, this is in AP. How? Because difference is same here. 3 minus 5 minus 3, 2, 7 minus 5, 2, 9 minus 7, 2, 11 minus 9, 2. And this is the condition of an AP. When difference is same, means common difference will be same, then we can say this is in AP. So this is in AP. So first condition satisfy, means we are adding plus 1, then we are getting same. This sequence is also in an AP. Same as it is, I am going to difference. I am going to subtract 1 in each term. Then we will see this is in AP or not. So see this here. 2 minus 1, 1. 4 minus 1, 3. 6 minus 1, 5. 8 minus 1, 7. 10 minus 1, 9. This is in AP or not? Check. See this here. 3 minus 2. 3 minus 1, 2, 5 minus 3, 2, 7 minus 5, 2, 9 minus 7, 2. Means we are getting same difference. So again this is in AP. Okay. So when we are subtracting means when we are subtracting same number in each term, then we are getting again result is same, means AP. Now I am going to multiply with 2. Multiply with 2. So 2 into 2, 4. 4 into 2, 8, 12, 16 and 20. Now see this here. What is the difference here? 8 minus 4, 4. 12 minus 8, 4. 16 minus 12, 4. 20 minus 16. We are getting same difference. Again common difference is same. So we can say this is in AP. Now what we are going to do? I am going to divide by 2. We will check divisor also. Divide by 2. So see this here. Actually our point is, what was the first point? If each term of an AP is added, subtracted, multiplied. So we have finished up to multiplied. Now we are going to divide by 2 in each term, and we will see this is in AP or not. So see this here. Dividing by 2, 2 by 2 1, 4 by 2 2, 6 by 2 3, 8 by 2 4, and 10 by 2 5. Now check this is in AP or not. Yes, again this is in AP. How? 2 minus 1 1, 3 minus 2 1, 4 minus 3 1, 5 minus 4 1. Yes, common difference is again same, means it means this is in AP. So see this, all the condition are satisfied. We have checked one by one, means added, subtracted, multiplied or divided by same number. Resulting sequence is also in an AP. Okay, so I hope you are getting this. Now property number 2 means highlight of an AP in this point number 2. What is the point number 2? Three numbers in an AP can be taken as three numbers in an AP. Point number 2, three numbers in an AP can be taken as A minus D, A and A plus D. So what is the meaning of this? See this here, three numbers in an AP can be taken as A minus D, A plus D. This is conventional actually. So actually the thing is that, can we take another things? Yes, we can take A plus D and A plus 2D, but calculation will be lengthy. But here what is the benefit, what is the advantage to take this A minus D, A plus D? After adding this we will get independent of D. How? See this here, A minus D plus A plus D. A minus D and A plus D, minus D plus D. After adding, what we are getting? We are getting 3A, means we are getting independent of D. So this is the advantage to take these numbers A minus D, A plus D. Okay, so I hope you are getting this. In the same way here, four numbers in an AP can be taken as A minus 3D, A minus D, A plus D and A plus 3D. Okay, now see this here, again same here. Why we are taking this? Actually after adding again we will get independent of D here. Minus 3D plus 3D 0, minus D plus D 0. So if you add these terms, so after adding what we will get? We will get independent of D. That's why we are taking this. So it means it is very important to remember this A minus 3D, A plus 3D, A minus D, A plus D. But how to memorize this? It's very simple. See this here, three numbers we are taking here. Okay, so three numbers means 3 is a odd here, so we need to check here, difference should be odd. A minus D, A here, so A minus, if you take difference, you will get D here. What is the difference between these terms? We will get D, means if number is odd, so difference will be odd. Now 4 is an even number, 4 is an even, so difference should be even. So see this, A minus D minus A and this one plus 3D. If you check difference, so A minus A cancel out, so 3D minus D 2D. So see this here, we are getting difference. What we are getting? Means difference we are getting here even. So if number is 4, number is even, okay, means terms is even, so difference should be even. If 3 number is there odd, so difference should be odd. Okay, so I hope you are getting this. So next point is point number 4. Point number 4, the sum of the two terms of an AP, the sum of the two terms of an AP, the sum of two terms of an AP is equidistance from the beginning and end is constant. So see this, what is the meaning of this? I am going to explain. See this here, the sum of the two terms of an AP is equidistance from the beginning and end is constant. Okay, why it is constant? See this here, you can understand easily. We have already seen sum of n terms of an AP. When we are adding a first term and last term, so we are getting 2a plus n minus 1 into d. In the same way, second term means a plus d, and second last term a plus n minus 2 into d. When we are adding, then we are getting 2a plus n minus 1 into d. Means after adding the first term, last term, 2a plus n minus 1 into d, second term and second last term 2a plus n minus 1 into d. It means we are getting same. So same meaning here. The sum of the two terms of an AP is equidistant from the beginning and end is constant. So I am going to take example, one more example here. See this here. Suppose 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, and we know that this is in AP. How? See this, 2 minus 1, 1, 3 minus 2, 1, 5, 6 minus 5, 1. Means common difference is same. So we can say this is in AP. Okay, now see this here. If you add first term and last term, this is first term, this is second term, third, fourth, fifth, sixth. So if you add first term and last term, so what you will get? 1 plus 6, you will get 7. 2 plus second term and second last term, 2 plus 5, 7. Okay, now see this here. Third term and third last term, means if you add this one, so you will get here 7. So see this. If a number is in the sum of the terms, the sum of the two terms of an AP, this is in AP. When we are adding first term, last term, 7, second term and second last term, 7, third term, third last term, 7. Okay, so from the beginning and end, second last, third last, we are getting same, means it is constant. 7 7 we are getting. Okay, so I hope you are getting this. Next point is point number 5. If A, B, C are in AP, then what will happen? So we know that if a given series in AP, so how to identify? Common difference should be same, then we can say this is in AP. So see this here. Here what is the difference of this and this? So I am writing B minus A. What is the difference between this and this? C minus B. Okay, and we know that difference should be same. For AP, this is the condition, means for AP difference should be same. So this and this difference should be same. So we can equate this difference and this difference. B minus A equals to C minus B. After equating, see this here. Now simplify this. So minus B and this one, it will come this side. So you will get here 2B equals to A. I am sending right side. So we will get A plus C. Okay, so we are getting here 2B equals to A plus C. Okay, from this we can say in this way also. This is very very important. If A, B, C are in AP, so we can say 2B equals to A plus C. And you can remember in a simple word in this way also, A, B, C are AP, so you can remember 2 times of this middle term, or you can say double of this middle term equals to sum of first and last. Means 2 times of middle term equals to first of sum of first and last. Okay, so 2 times of middle term means 2B equals sum of first and last, A plus C. So 2B equals to A plus C. So this is. Now we are going to discuss arithmetic mean. Arithmetic mean. Arithmetic mean. Or you can say in short AM. You can say in short AM. Now see this here. What is called arithmetic mean? See this. If A, B, C are in AP, A, B, C are in AP, so we know that 2 times of midterm equals to sum of first and last. So we can write in this way. See this, common difference, we know that common difference should be same. So difference of this is B minus A equals difference of this C minus B. After solving this, we will get here 2B equals to A plus C. And if you divide by 2 both sides, so you will get here B equals A plus C by 2. So from this we can say B is the arithmetic mean of A and C. Okay, see this here, A, B, C are in AP, so we can say B is the arithmetic mean of A and C. How? See this here, B is here, B equals to A plus C by 2, means it will be like average. Okay, so you can say here B is AM, means arithmetic mean of A and C. Okay, so you need to remember here what we are doing here, means B equals to A, B, C are in AP, so we can say B equals A plus C by 2, means B is the arithmetic mean of A and C. If 4 terms is there, A, B, C, D, so we can say that B and C is the arithmetic mean of A and C. If 5 terms will be there, then we can say B, C, D is the arithmetic mean of A and E. Now we are going to discuss very important topic, name is to insert an arithmetic mean between A and B. Next heading is, our next heading is to insert an arithmetic means between A and B. Our next heading is to insert an AM's arithmetic means between a small a and a small b. So see this here. This is very important. To insert an arithmetic means between a and b. So first of all I am going to consider arithmetic means. First, capital A1 means first arithmetic mean. Second arithmetic mean A2, capital A2, capital A3, third arithmetic mean. In this way, n arithmetic means capital AN. Okay, so I am going to consider first arithmetic mean capital A1, second arithmetic mean capital A2, third arithmetic mean capital A3. In the same way, n arithmetic mean capital AN. Now, what is the heading? Our heading is to insert an arithmetic means. Okay, between A and B. So see this, I am going to insert. This is A here, this is B, and I am going to insert this means an arithmetic means between A and B. So A1, A2, A3, in the same way AN. Okay, so we are going to inserting here A1, A2, A3, AN between A and B. Now see this here, you can notice one thing here. From here to here, how many terms are there? Total terms are n terms. How many terms are? See this here, n. A1, A2, A3 up to n. 1 to n, n terms. This is one term, single term, and this is one single term. So now how many terms from here to here? If you add the all terms, so you will get here total terms are n plus 2. N plus 2. How? See this here, from 1 to n terms plus 1 means 2. So n plus 2 terms. Now we know that one more thing here, nth term of an AP. Nth term of an AP is Tn equals to A plus n minus 1 into D. When we apply this formula, when terms are n, but here terms are not n, here terms are n plus 2 terms. So what we will do? Instead of n we will write n plus 2, simple. So n plus 2 equals A plus, instead of wherever n is there, I am going to put n plus 2. So n plus 2 minus 1 into D, simple. Instead of n we are going to substitute here n plus 2. Now see this here, this is last term. We know that Tn is last term, or you can say nth term of an AP. So this one is here last term. What is the last term given here? B. Okay, so I am writing here B equals A plus n plus 2 minus 1, n plus 1, okay, into D. So after solving this, you will get here D equals B minus A divided by n plus 1. Okay, so this is the formula for finding to insert an arithmetic means between A and B. So this is D equals to B minus A, or you can say in simple word, last term minus first term divided by total number of terms plus 1, n plus 1. Okay, so